Mad Montreal Man. Last time we were talking about the Big Bang in a quick little summary of what was wrong with it. So today what we're going to do is we're going to look at the Big Bang. I'm going to explain to you what I've discovered over the years and how we can actually fix the Big Bang. It's a big universe after all, and it's about time that we roll up our sleeves and start thinking about it in that way. It's bigger than human comprehension can take. See, that's been the problem with most physicists over the years. They only think in human terms. They got the blinders on. So right now, you ready? Quantum Physics 101B. Okay, just to recap. You have the Big Bang. Nothing in space. Big explosion. Woo! Thing goes in every direction. Okay? Problem with the old Big Bang theory, in recap, is that you have light. Oh, that's 4.5, 8 billion, 10 billion, and there's nothing in between. A lot of physicists have always said, oh, it's dark matter, it's this, negative matter. Well, if you think of it this way, okay, in space there's no friction, correct? So if you think of it this way, if you think of the Big Bang as a pond, you drop a rock into a pond, what do you have happen? Whoosh. So here's your Big Bang right here. There's the rocket hit. Well, on this top of the wave, right here, wow, I can see everywhere. But what if you're on the ripple that's over here? Okay, well, you'll be able to see there. You might see there. You might, oh, you missed one. Guess what? So think of the Big Bang maybe as a giant rock. But getting back to the point, the Big Bang Theory in itself has got some flaws. You've got this giant explosion, goes out into space, you've got gaps of light. Well, last time I looked, you got one explosion, whoosh, all the material goes out. Well, how do you explain how you have different layers of light? Okay, that's the problem with the Big Bang Theory. Not only problem with that is you got the problem with how you have galaxies coming at different angles. Some physicists want you to think that space is a cone, that somehow gravity spins stuff back on itself. Okay, that's a possibility. I haven't seen proof of this in my own research. So now we're going to get into my theories on the Big Bang. When you look at the universe, everything around us, okay? Let's start here on planet Earth. You've got a planet. This planet has a moon. And we're around a sun. Now what happens? This goes around us, we go around that. It's a circular pattern, isn't there? Well, then you expand this to our solar system as it spins around the great Milky Way. See what I'm getting at here? Things go in circles, they're spinning. Recently, the Nobel Prize for Science was given out to a physicist who sort of proved in theory that the universe is expanding faster and that will probably cool down. Okay, he had a point to his theory, but once again, they're thinking in human terms. So what I did over the years of reading about the Big Bang and thinking about it was I came to realize there's certain things. Patterns repeat. So yes, chaos theory, string theorists, people out there, you know what, you all have a bit of a point, but you're all still thinking with blinders on. There's a little known thing out there, most physicists know, called pulsars. Pulsars are a star that collapse. As it collapses, it becomes smaller and denser. Now as it spins, it jettisons material. In other words, this little spinning guy here, okay, this star is sending out on a routinely patterned rotation its light, its ejected energy. So you think, if a star can do that, why can't a Big Bang do that? So once you take that into thought, here's your Big Bang. Right? We have the initial explosion. Boom! Everything goes out. But what if that Big Bang is still ongoing? Instead of just thinking of it as, oh, it was one big explosion, boom, what if it's such a large collapsed star, or a large whatever you want to call it, that it actually is still spinning, and as it spins, this is how you get your light. See my point? This would also explain why, in between all these wonderful patterns, we have those gaps. Because, yeah, there's no spin here, but it's spun out over there. It's spun out there. The universe is so big, you can't think, oh, in human terms, well, if we can't see it, it's not there. This makes more sense. A continuous Big Bang, it's still going on. We can't see it because we're not in that rotation. I know many people are thinking, well, we'd see it by now. Well, we've seen the proof. Think about it. We have light at certain intervals, in billions of years intervals. We haven't been around that long to see the next Big Bang explosion from there. So that explains how the Big Bang could actually have functioned, and it is functioning today. Okay, now you're arguing, well, what about those tachyon particles you've talked about in galaxies coming at different angles? This brings us to Big Bang 101c. Okay, so here's our Big Bang. Okay, boom, boom, boom. Oh, it's going this way, that way. Okay. Now, we know that tachyon particles have the appearance of traveling faster than light. Let's say here's our little planet Earth. We'll say, well, we're one of the newer ones, so we're down here. Okay, so how do you explain tachyon particles that have done this? Whoosh! Aha! You wonder. How do you explain that in the great universe you have galaxies coming in at angles like this? You've got galaxies going like that. Well, if you think in human terms, you're stuck. But once you say, hey, I'm not going to think in the small human terms. I'm going to think in a grander scale. I'm going to go beyond human reasoning. You go, hey, well, if there's one Big Bang, why not a second or a third? I mean, we know there's more than one star. And all of a sudden, once you realize that, you got tachyon particles flying every single direction you can think of. You've got galaxies coming in every direction you can think of. My God, it makes sense, doesn't it? See, I've had this in my head for over 20 years, and it makes sense. Why? Because I stopped thinking about it in small terms. That explains your tachyon particles. That explains pretty much why galaxies can come at different angles, and all that other wonderful stuff. Pretty scary, huh? Me, Mad Montreal man, over 20 years ago, came up with this, and I'm still adding to it every year. Well, this has been Big Bang 101B and 101C. Tell you what, come back next time we'll do Quantum Physics 101.